Night, 6:31 p.m. We're not quite into sky dark yet, but I gotta get it going. It's the 15th of February, 2026. As I said, about 6:30, and what you're seeing there is the brilliant Rigel, a near zero magnitude star, Alpha Orionis. And we're going to be spending a lot of time in Orion this evening, and I don't want to give it away, but we may actually encounter some of the most brilliant deep sky studies possible in the night sky. So let's move on. I'm going to capture uh, far north studies first, JIC, and then we'll come back to them if necessary later on in the evening. And hopefully we will not lose anything to roof tries. So here we go. Let's move on. Beautiful stars in the background of Rigel, aren't they? Okay, this is a beautiful little tight open cluster, NGC 1907 in Auriga. What a spectacular field. We have already imaged this open cluster earlier. I do not recall its name. But let's go ahead and isolate on this one. Kind of condensed. It's magnitude 8.2, 7 arc minutes in size with some 30 stars. Its brightest stars are magnitude 11.3. Typically in an open cluster, the brightest stars are typically 3, maybe 4, but mostly 3 magnitudes brighter than the cluster as a whole, which would mean this would be 11.2, 11.3. So we'll call it 3 magnitudes. This is a class 2-1. Class 2 has to do with condensation, and class 1 has to do with disparity of brightness. And it looks like there's quite a few bright stars here. This cluster is located 5,500 light years distant, so it's about 30,000 light years from the black hole in the center of our galaxy. And the reason I can say that is because Auriga, where this cluster is located, is the antipode or antipole to the summer sky Sagittarius, almost Scorpius border where the center of the Milky Way is located. We're at right ascension 5 hours, 28 minutes, 5 seconds with a declination plus 35, 19, 30. Let's go ahead and seek out some more far north studies before we dive deep down south. Aha, that other bright cluster I did image before is now NGC 1912. It's an open cluster in Auriga. It's collectively brighter and was discovered by Charles Messier as number 38, magnitude 6.4, 21 arc minutes in size, with our neighbor there, NGC 1907. They both fit in the field of view. Its brightest star, its magnitude collectively is 6.4, 21 arc minutes in size, 100 stars. Its brightest stars are magnitude 9.5. Once again, that 3 magnitude delta. It's a class 3-2, which means it's less condensed than NGC 1907, but it's equally in terms of distribution of brightness. We're at right ascension 5 hours, 28 minutes, 40 seconds with a declination of plus 35 degrees, 50 minutes and 54 seconds. NGC 1931 is a nebula in open cluster. And oops, played with that again. It's a nebula in an open cluster in Auriga. Collectively, magnitude 10.1, 10,100 light years distant, pushing it out to about 35,000 light years. It's a class 1, highly condensed 3 with some disparate stars. 10,100 light years distant, like I said, 35,000 light years out roughly. RA is 5, 3125 with a declination of plus 34 degrees, 14 minutes and 42 seconds. And I do want to push it up to 150x view to gather as much photonage as possible. Okay, NGC 1952 probably got Messier pretty worked up when he first saw it. However, it turned out to be not a comet, but a supernova remnant in Taurus, and he listed it as the first entry in his catalog. M1. Magnitude 8.4 collectively, 8 by 4, which means about 32 arc minutes in size, which gives it a magnitude of average Surface brightness, maybe 12.5. I'd have to calculate it. 6,500 light years distant. RA is 5 hours, 34 minutes, 31 seconds with a declination of plus 22 degrees and 52 seconds. This particular nova blew up in 1054 and was noted in various locations throughout the planet Earth by those who kept records at the time, particularly the Arabs and the Chinese. NGC 1960, and because the Olympic ice skating is going on at this time, plus other events, I named it the skating pairs. So you've got the man holding the woman, skating on one foot and going down the ice. This open cluster is in Auriga. It's also known as Messier 36, magnitude 6, 12 stars, 12 arc minutes in size, 60 stars, and the brightest is magnitude 8.9, which once again is roughly 3 magnitudes fainter than the cluster as a whole. It's a class 2, which means fairly condensed, 3, which means stars are of disparate brightness, 4,300 light years distant. RA is 5 hours, 36 minutes, 18 seconds, with a declination of plus 34 degrees, 8 minutes, and 24 seconds. Okay, we're off to NGC 1985. It's a nebula. I'm seeing some nebular content there in Auriga, magnitude 12.5. This is a fainty. The central star, it says it's got a star associated with it, magnitude 13.5. It's very small, 0.7 arc minute, as you might be able to notice. This nebulosity is reflective type, 5,900 light years distant. RA 5 hours 37:47 with a declination of plus 31 degrees, 59 minutes, and 19 seconds. Okay, NGC 1996 is simply described as a group of stars. Maybe I had to back out on it. In Taurus. It could be a cluster, but basically you'd be wanting all the stars to be roughly the same distance. And that would be determined by the amount of luminosity lost due to intervening gas and dust in the Milky Way, largely. We're at RA 53810 with a declination of plus 25 degrees, 49 minutes, and 2 seconds, and there is no information available on NGC 1996, 4 years before the millennium change. Okay, here we get to see just how dark the sky is tonight. I'm telling you, there was this huge atmospheric river that was heading in our direction. And then it swirled off the coast, making this dark sky possible for at least an hour or so. This, of course, is a globular cluster, and you might assume it's probably bright enough to have been discovered by Messier, even though he was at 49 degrees northern latitude. And you'd be right. It's in Lepus the Hare, otherwise known as Messier 79, magnitude 7.7, smallest 7.8 arc minutes in size, brightest stars are 13.1. So when you subtract from a globular cluster the brightest stars from the total magnitude, you typically get something between 5 and 7 magnitudes, and in this case it's about 5.5. This is a class 5, which means a little more condensed than most. A class 6 would be the middle. 41,000 light years distant, RA 52410 with a declination of minus 24 degrees, 31 minutes, and 29 seconds. Well, as it turns out, NGC 1906, a galaxy in Lepus, is behind the diffraction bar associated with a power line. It is a magnitude 14, so it could be photographic, it could be visual, 0.9 by 0.5 arc minutes in size, spiral with a lowercase cd, so it shouldn't have a very well-defined core. We're seeing the galaxy pretty much in its extension there. 132 million light years distant, puts it about 40,000 light years in diameter. RA 52447 with a declination of minus 155634. What we may or may not have here is a very large nebulosity in Eridanus. 180 by 60 arc minutes, reflective nebula. I don't think we're going to make this out at all. It doesn't give a magnitude. It's only 900 light years distant. It's at right ascension 5 hours, 4 minutes, 54 seconds with a declination of minus 715 and aught arc seconds. So there is, I am seeing some nebulosity frontiar in through here. So very intriguing. We are seeing some nebulosity, but it's huge, expansive, no magnitude, and probably something like magnitude 16 overall, 15 or 16 in terms of average surface brightness. Okay, NGC 1924 is quite visible right in the middle of the 30X field, so you know it's a brightie. Galaxy in Orion, magnitude 12.5, but kind of small. 1.6 by 1.2 arc minutes, spiral with a bar in lowercase bc, and a ring. And I've discovered I really like 105X. We are fully making out its frontier, its angularity. That angularity is going to be somewhere around magnitude 16, 16.5. It's 112 million light years distant, so smallish, maybe 40,000 light years in diameter. RA 52802 with a declination of minus 5, 1838. We are having a fine, transparent sky. NGC 1954 is being masked to some degree behind the diffraction bar. It's a galaxy in Lepus, bright, magnitude 11.8. And we'll press it up. You can see the core there. There's several other galaxies present in the field. 4.2 by 2 arc minutes, spiral with a lowercase bc, 134 million light years distant. So larger than Messier 31, maybe 170,000 light years. RA is 532.48 with a declination of minus 1403.46. Okay, now a neighbor is NGC 1957, a galaxy in Lepus. And it should be right about there. Magnitude 14.8, 1.1 by 0.8 arc minutes, rather bright core. Since it's elliptical, we could probably figure it's around magnitude 13 plus. 147 million light years distant, puts it at about 50,000 light years. RA is 532.55 with a declination, once again, minus 1407.59. NGC 1964 is a galaxy in Lepus, also in a diffraction bar. It's a magnitude 10.8. Giving a nice edgy-on appearance. 5.5 by 2.1 arc minutes. Brilliant core, so what do you think? Spiral with a bar and a lowercase b. 71 million light years distant, puts this at about 120,000 light years in diameter. RA is 533.21 with a declination of minus 2156.46. And if we didn't have this diffraction bar, boy, the sky looks really good deep south, doesn't it? Okay, we're going to finally get clear about NGC 1973. It's a nebula in Orion, magnitude 7, 5.5 arc minutes in size. I suspect it's this part of the nebulosity here because there's a break here. And let's disregard this craziness over here. So it's an emissive type nebula. It's kind of bluish, not reflective. 1,600 light years distant, like the rest of everything else here. In the Orion subspiral arm. We're at right ascension 535.04 with a declination of minus 4 degrees, 43 minutes, and 54 seconds. So now you know where the sword is, about minus 5 degrees down from the celestial equator. All right, it's possible this part of the nebulosity is in fact NGC 1975. All of this is one nebular cloud of star formation. It's magnitude 7, 10 by 0.5 arc minutes in size. Yep, that qualifies. It's elliptical. It's emissive. 1,600 light years distant. Right ascension is 535.18 with a declination of minus 4 degrees, 41 minutes, and 5 seconds. Really looks seriously good there, doesn't it? Great sky. Okay, I figured something in here would be next, but that's not the case. This, what we're seeing right here, is NGC 1976. Let's fill the field. Nebula in an open cluster in Orion. Of course, it has the famed trapezium of stars, which means 5 stars. Actually, there's 6 that can be resolved with a 6-inch scope, as I recall. It's otherwise known as Messier 42. It's magnitude 4 totally, 90 by 60 arc minutes, and basically it spills outside the field of view here. You can see nebulosity all the way up into this corner and down to there. It's an emissive and a reflective, 1,300 light years distant. 300 light years closer than 1973 and 5. It's interesting. I always thought it was 1,600 light years distant. RA is 53516 with a declination of minus 5 degrees, 23 minutes and 24 seconds. Hello, Great Nebula in Orion. Okay, NGC 1977. This was a little bit west. It depends on where you calculate the center of NGC 1976, I believe. This is NGC 1977. I'm waiting for data to come up on it. It's a nebula in open cluster, as you can see, in Orion, part of that same extended study. Magnitude 7, 20 by 10 arc minutes, the largest, emissive and reflective, 1,600 light years distant. So all of this is a backgrounder to Messier 42. RA is 53516 with a declination of minus 4 degrees, 51 minutes and 8 seconds. Let's go ahead and frame it up, just the whole series up, excluding Messier 42. And that's our, I think it's about a 75x view. Quite beautiful, isn't it? Well, we've gone deep south here, and it looks as good as anything further north on a poorer night. What we're looking for here is NGC 1979, a galaxy in Lepus the Hare. Its magnitude 11.8, 2.2 by 1.8 arc-minute lenticular spiral, 68 million light years distant, so 50,000 light years in diameter. RA is 53401. Here's a 105x view. And declination is minus 23 degrees, 18 minutes and 35 seconds. Very, very nice. And it shares the space with other galaxies. And these will be further to the east. We may encounter them this evening. Okay, what we're looking for here is another nebula, an open cluster, and that'll probably be this one right here in Orion. Magnitude 2.5, 14 by 14 arc minutes. That 2.5 is basically dominated by these bright stars. It's a class 3-3, which means spread out and a lot of disparities in brightness. Of course, we're getting lots of satellite passages because since we're near the celestial equator. Let's go ahead and do some zoomage and isolate it unto itself. One more step, 105x. 14 by 14 arc minutes, 1,800 light years distant, so it's a background study to Messier 42. RA is 53524 with a declination of minus 5 degrees, 54 minutes and 54 seconds. Now, how this happened, I do not understand. This is west. We should have encountered this open cluster with nebulosity in Orion earlier rather than later, but there are anomalies like that in the NGC catalog. I'm going to assume this is our open cluster. Let's see if it maps. Magnitude 4.2, okay. 25 arc minutes in size, yeah. 20 stars, okay. Not particularly well populated. Magnitude 6.3 are its brightest stars. Okay, I can live with that. It's a class 3, which means distributed, not very condensed. 2 stars are a little closer in magnitude. The brightest stars are magnitude 6.3, as mentioned. It's 1,300 light years distant, so it's in the same region of space as Messier 42, the Great Orion Nebula. RA is 53509 with a declination of minus 4 degrees, 25 minutes and 54 seconds. All right. NGC 1982, of course, also has a Messier designation of 43. In the 109 initially, but eventually 110 listed studies in Charles Messier's catalog. Magnitude 7, 20 by 15 arc minutes. Now, I describe this as the conch shell nebula. It's emissive, and this may be where I got our 1,600 light years distance for M92, because Messier 43 is 1,600 light years distant. Therefore, it's a background study by about 300 light years. RA is 53531 with a declination of minus 5 degrees, 16 minutes and 3 seconds. And let's go to that 105x view. And okay, how good are the skies? Well, this good. We're having a view right now of NGC 1989, a galaxy in Colombo, I believe. Magnitude 13.1, 1.4 by 1.1 arc minutes. Lenticular spiral, 481 million light years distant, puts it about 180,000 light years in diameter. Boy, massive, mature, brilliant. We're at right ascension 5 hours, 34 minutes, and 23 seconds. And by my reckoning, I should not even be seeing this tonight because we're at minus 30 degrees, 48 minutes, and 3 seconds. My presumption is we can see on the best of nights galaxies down to magnitude 14 at minus 30. This is standing out at magnitude 13.1. And this is a very good night of seeing transparency. Okay, we have NGC 1990. It is a nebula in Orion. 50 by 10 arc minutes, completely overpowered by this brilliant star, which is probably up in Orion's belt. I'm not sure which one it is. Not Alnitak, because we would see other nebulosities around it. It's 50 by 10 arc minutes. Should spill outside the field of view. Let's see if we push this off and see if we can make out any of the nebulosity. It's an emissive and reflective. And I'm not making out anything here, but the star did center. So it's probably the source of the luminosity. 1,300 light years distant, so about the same distance as the Great Nebula. RA is 53612 with a declination of minus 1 degree, 12 minutes and 6 seconds. And that's where we ended up to begin with. Okay, we're doing another one of those outside-the-box explorations. We are having a look at NGC 1992, another galaxy in Colombo. Magnitude 13.6 this time, 1.1 by 0.7 arc minutes, spiral with a lowercase a. And here is its confrere. So this is the second galaxy, 472 million light years distant, obviously part of a group. There are probably many faint galaxies here. We're only seeing the brighter ones. RA is 534.31 with a declination of minus 30 degrees, 53 minutes, and 48 seconds. NGC 1993 is a brightish galaxy in Lepus the Hare, magnitude 12.4. 1.5 by 1.4 arc minute, lenticular spiral, 135 million light years distant, maybe 70,000 light years in diameter. RA is 5 hours, 35 minutes, 25 seconds with a declination of minus 17 degrees, 48 minutes, and 55 seconds. We are 23 and a half minutes into this video. Not bad. Okay, NGC 1999 is our last study in the NGC 19,000 to 1999 series. And what we're obviously seeing here is a star with nebulosity. Let's get our 105x view. 2 by 2 arc minutes. Boy, look at that void. Wow, Barnard must have loved it. He loved those dark nebulosities. Emissive and reflective. 1,500 light years distant. We got a pair of streamers, slow walkers going through the field. Actually, I'm seeing a third now. That's rather extraordinary. I'd love to see somebody make a right angle turn so I can declare you a UFO, a real super aeronautical craft. 1,500 light years distant, RA is 536.25 with a declination of minus 6 degrees, 42 minutes, and 57 seconds. I am going to leap ahead for our final view of the evening since we're only 24 minutes and 35 seconds in. Okay, we actually have 3 nebulosities in this field plus a dark nebulosity as well. We all know this one's called the Flame, NGC 2024 in Orion. This star is Alnitak, one of the bright second magnitude stars in Orion's belt. NGC 2024 is full moon size, 30 by 30 arc minutes, so basically it should go out to about here. 1,500 light years distant. You can tell it's an emissive nebulosity because it's glowing red. That means it's got lots of those excited electrons falling in and out of orbitals. There is also a reflective nebulosity here. I believe it's NGC 2023. It's got a bright progenitor star. All this stuff will be probably turning into an open cluster in no time flat, maybe the next 50 to 100,000 years. I don't know for sure. We also have an extended range of nebulosity because there's probably quite a few stars forming in this open cluster here. Not sure of its designation, nor will I pursue it this evening. We will get a chance to revisit this scenario in the next night out, and hopefully it will be as good a night out as this one has been. Once again, NGC 2024 for our Carpe Noctem view. Okay, a wee bit of a tag on this one. Of course, we are looking at bands on the run, Jupiter at some 450x. It is well into the sky's middle third. We are getting a fairly decent view, and if we were to stack this, it would be quite sharp. But you have to take multiple images, and then you have to manually stack them, and that requires much more time than I have on my hands. Thought I'd share this as a tag. Once again, Carpe Noctem.